Hello students. Today we're looking at activity 2.1.5, securing a sloppy code. This activity is about debugging your code and the different types of errors that can occur in your programs. This is a part of the security unit because it's important to write solid code, because if your code has design flaws, it can be vulnerable to attacks. So we're going to look at different kinds of errors and how to fix those errors in this lesson. A lot of this will be review for us. All right, let's take a look at number one. In number one, we're going to hit play. It's going to ask us a series of questions. If we answer yes to all these questions, we get a response that we have good security habits. But what if we run it and we answer yes to most of the questions, but maybe not all of them? No response. Go ahead and pause the video and see if you can figure out, one, why don't we get a response when answering no to some of these questions? And two, how can this be better written so that it will say you can improve your security habits if we answer no to any of the questions? All right, hopefully you answered that. The reason we only get a response for no, the reason we don't get a response for no for all of them is because the else only is attached to the very first if. So if we answer no to the first question, and then it doesn't matter what we answer to the other questions, then it'll say you can improve your security habits. Now, to fix this, we could write an else block for every single one of these ifs, but that would just be repeating the same code over and over and over again, and you'd have just a big old nasty section of code with a whole bunch of elses. So how could we combine all these conditions into one so that if we say yes to all of them, it says you have good security habits, but if we say no to any one of them, it'll say you can improve your security habits. Well, the way to do it, of course, is to use an and block. We'll say this and this and this, and you can take out the parentheses if you want, they aren't necessary, and that. And that should do it. Now, if we answer yes to all of them, it will say that we have good habits. But if any one of them does not say yes, then it will say you can improve your security habits. Okay, that was an example of a logic error in our code. It's not like the program broke while we were running it. It's not like we had a syntax error. Syntax errors are like if you don't have matched parentheses or you forget a semicolon. Those weren't the issues. Our program ran, but it did not work as we expected it to. That's called a logic error. And having logic errors can cause real big problems in programs if they don't run how you expect it to. Okay, they talk about using ands and ors here in this Boolean logic section, which we have learned about ands and ors in the past. If you need a review of that, go ahead and read that section. Before we move on, let's look at number 5. How could we rewrite this code using or blocks instead of and blocks so that we get the same result? If we said no to any one of the questions, then it should say we can improve our security habits. If we want to check to see if we said no to any of them, we would go this or say no to each one of these. So I've rewritten the code to check to see if we answered no to any one of these, and I used or blocks instead of and blocks. So I basically reversed the logic of the code, and so I now need to reverse the print statements. So switch them around, because if I said no to any one of those, then it should say you can improve your security habits. Okay, next let's talk about runtime errors. A runtime error is a mistake in the program that occurs during the execution of the program. So again, not a syntax error. If you have a syntax error, your program doesn't run at all. It won't even start. But a runtime error means in the middle of executing the program, an error occurs. Let's go ahead and click on the link that I provided for the generate keys program and all the other encoding encryption files that came with it. And we're going to run the Rsa encryption program, which asks you to put in a key and a modulus. But what if we don't put in a key and a modulus? So again, we're going to run Rsa Encrypt, and it asks us to enter an encryption key. What if we put in something like numbers instead of letters? Oh dear, we get an error. Okay, this is an example of a runtime error. The program expected us to put in an integer because it's using the int function. It's trying to convert our text to an integer. And we supplied an invalid literal for the int function. In other words, we put in a string and it's having a hard time converting that string to an integer. This is a runtime error. And if you write good code that does not have design flaws, you will handle user errors like this. You don't want users to be able to break your program because sometimes that can actually lead to security breaches if your program breaks. So you want to write code that is rock solid and will not break even if the user is a dum-dum and enters in something incorrectly. All right, so we're going to look at ways to prevent user error from breaking our program. And one of the ways to prevent that is to check the input of the user. Anytime your program allows user input, then you are allowing the user to kind of dictate what happens to the program. And if you're expecting a certain kind of data, you need to ensure that the user entered that kind of data. One way to ensure that is digit function. The isDigit function is provided by Python, and it works on strings. And it can check to see if a string is a digit or contains only digits. Okay, go ahead and take a look at the multiple choice problem here, or the multiple select problem number 10. What do you think? Which of these will return true? Go ahead and make your selection and check your answer. So you can see that A, B, and E are the correct answers because isDigit only returns true if the only thing in the text is digits. If there's any non-digits in the text, like commas or letters, then isDigit will return false. All right, so we're going to improve Rsa Encrypt so that it won't break if we enter something that's not a digit. So the main thing we need to fix here, and again, go click on the Rsa encryption file. The main thing we need to fix here is we can't just convert straight from the input to an integer, because if the user doesn't enter an integer or a digit value, it can't be converted to an integer. All right. So what we want to do first is we want to just save the input using a variable. You can keep the variable key as the name. but we want to check key to see if it is a digit, all right? So we could do something like this. We can go if key dot is digit, and for testing purposes, we can go, just like a simple valid, not valid. And we can try that out. All right, so if I enter text, it gives me not valid. If I enter a number, it gives me valid. What about spaces, you might ask? If I do number, space, number, that is not valid. Spaces are not digits. Okay. Now, instead of doing a simple if-else, though, when you are asking for user input and expecting a certain kind of thing, you need to keep asking until the correct thing is entered. Because if I continued on and just did this anyway with bad input, it would still break. Okay, it's not good enough to tell the user that it's valid or not valid. You actually have to force them to do the correct thing if you're going to go forward and do the encryption. So instead of an if block, we need to keep repeating until they enter something valid. So we're going to go while not key is digit. Right? We're going to check to see if the key is a digit or it contains only digits, and if it does not, we'll ask them again. So we can keep this print not valid, and then I'm going to copy and paste the input line here, and we're just going to keep asking. Let's go ahead and try this. So if I enter letters, not valid, do it again, and it just keeps asking us to do it again. Even if it contains some letters, we have to do it again. And then finally, once we enter all digits, it will stop asking us to redo it, and it'll move on to the next step. Okay. At this point, we need to go ahead and convert key to an integer now, because it is an integer and therefore can't be converted to an integer data type. Because it is still a string when we use the input function. It has to be converted from string to an integer. So we just go key equals the integer of key. Convert that. All right. See if you can do the same thing with the modulus value on your own. Now, similar to the isDigit function, there is also an isAlpha function that checks to see if a string consists entirely of alphabet letters. So again, go ahead and select from the choices here which of these would return true for a string that contains only alphabet letters. So you got to be careful with this one. Obviously, the 1, 2, 3 hello would not return true, but spaces are not alphabet characters, so that doesn't return true either. And then this one has periods, so that one's no good either. The only good one is the top one.